So suddenly your video camera can go from recording 4K at probably about 50 megabytes a minute to 10 megabytes a minute. I made the claim that AV1 was the codec to beat all codecs. Don't beware, that's a threat, right? I mean, a 100 gig video just to watch a half-hour movie in an 8K VR stream.
Can they actually get that to a sort of, power and performance capability that works for mass volume at kind of 30 quid?
Any TV based on Google TV or LG WebOS today, even 3 years ago, plays AV1. AV1 is already taking over the world. And I'm sure there's a lot of professionals here that are going to have other opinions, so I'm going to welcome all debates, and we'll see how it goes down. Hello, everybody. My name is John Boero. I am a transplant from DevOps and DevSecOps London as well. This essentially is me defending a drunken bet I made with David and Paul at the pub afterwards. I made the claim that AV1 was the codec to beat all codecs. At which point they informed me about this meetup, which I was happy to attend at the game show of, had a great time. Loved the post-production on it as well. And I'm field CTO at TerraSky. Ironically, when I was having this pub discussion afterwards, after the DevOps London debate, I was taking the summer off, having the time of my life. And currently, I'm here to help a company called TerraSky based in Israel, is a DevOps consultancy and cloud consultancy to grow the UK. So that's my day job. Formerly Red Hat, Puppet, HashiCorp, actually Red Hat US for the first 3/4 of it. I came over to the UK about 9 years ago, right? And you can see that the progression goes into automation, right? Everybody DevOps vendor space, right? I'm from Chicago. I'm a bit of an industry critic and an author. Anybody use Packer here? A few hands, right? Okay, I think I've got the most current book on Packer published. It's a charity project. Any commissions on that go to support the Raspberry Pi Foundation for kids learning how to code. So if anybody wants to get involved with that, let me know. I'm active in the Fedora community. Best thing that I picked up at Red Hat, I'm a big open source fan and contributor as well. So I'm among the right people, I think. And media is, I'm a generalist. Media is kind of a niche thing that I've done on and off during my career, either consulting at Red Hat, back when streaming services in the US were designing their DRM ISP caching boxes, all the way to, I think I've done, I don't know, a couple of you maybe used Puppet back in the day I made some visits to a couple of the studios with Puppet, and also in Germany, I think with one of the channels and streaming companies in Germany I've worked with as well. So a bit on the spectrum, so beware. No, don't beware, that's a threat, right? I mean, not that much on the spectrum, sorry. Avid sailor, in fact, tomorrow morning I've got to head down to the coast and go sailing. And then media rendering streaming geek. And there was a question. No? Okay, cool. LinkedIn is there. I'm a bit of a cloud boy, so I would love to have that up. And then the remote stops working. What's going on here? There we go. Why AV1? Okay, who here is familiar with AV1? Yes, a lot of people, I hope so, at least have heard of it, right? The 2 points in time here, 2 snapshots of the data of the world's internet bandwidth, right? 2015, in the area of HD before 4K TVs and streaming and VR headsets, roughly 75% of the internet's bandwidth was streaming. The adult entertainment industry, ironically, is included in the 25%. I don't know how that's possible back then, but it seems to have been excluded from that. And now here, 2022, we have a 4K era. We have VR headsets that need 8K streams. Ironically, tonight we're doing an experiment. There is a 3D camera in the back recording this. If we can watch this later in people with VR headsets or Apple Vision Pro headsets can watch it. And one of the points I'm making with that is that I'm not even sure if that 128 gig memory card is going to be enough. So we'll see. If it stops halfway through, I might lose something. But the reason for AV1 is that it's time for a new standard, right? So today's digital broadcasting and standards that are using MPEG-2 and H.264, were designed in the 80s and 90s. And this is obviously something that interests the companies that are involved. The Open Source Alliance for Open Media, a conglomerate of Netflix, Google, or Alphabet, Apple, and I think, I don't know, one or two other streaming services, they are spending a lot of money on bandwidth, right? This is unicast traffic. This is not broadcast anymore. This is something that, again, when the streaming services came to us at Red Hat, we need a box that our ISPs can install so that they're not doing 50 unicast streams through their uplink, right? This is insane. So imagine that now with 4K, with 8K and VR videos, potentially a 100 gig video just to watch a half-hour movie in an 8K VR stream, right? So this has to change. They've come together, they've created the standard, and they've done it in a way that is open source, right? So they don't want to have to pay royalties. They don't want anybody in their competition to have to pay royalties. They're doing this about the greater good of minimizing internet bandwidth, right? Wasting internet bandwidth for this. Because obviously the need is growing. Anybody buy a 4K TV on Prime Day or for the holidays, it was like 200 quid, right? I mean, everybody's got 4K TV now. It's time to have a more modern standard. So why not AV1 and David and a couple of people that were debating? I'm sure I'm going to get hell from a couple of people afterwards. Historically, it's been lacking device support. A lot of people will say it doesn't play on anything, right? I'm going to show how that's not entirely true anymore. The last 2 years have come a long way. I'll give the state of Android decode support and the state of Apple decode support. Like, remember, does anybody see something missing here? In these lists of companies?
Amazon? Prime. Is there?
Prime's down here, 2.8. Apple, yes. And I think this is kind of interesting and telling to me. I don't know why. This is from Statista. That's hard to say, sorry. And I'm sure that they probably have data on that. Maybe they didn't include it. But I think the reason Apple is not listed here is a little bit telling, okay? Because Apple is a member of the AV1, Alliance for Open Media the consortium that does this for free, but they don't use it. They don't support it on their hardware. So anybody with a Mac M2, M1, the new AVP headset doesn't support AV1, right? So another reason maybe not to use it, the next generation in commercial codecs, H.266, which is also known as VVC, is coming potentially. And I actually, during this research, came across a blog from BBC, and I'm curious if anybody knows the people that wrote this, or maybe they are in this room. But they did a report in 2019 that said that VVC was actually better than AV1, in a time when AV1 wasn't quite ready yet. So I think it needs to be updated. But I'm curious if there anybody in this room knows who did that, right? Also, the debate was hardware encoding support is rare, and that's no longer true. Okay, so this is a lot more common now. So the expected results, again, this is from the BBC blog, which I'm not sure if I agree with. Maybe it was valid in 2019, maybe not anymore. James Bruce, Marta Mrak, and Rajitha Virkadi. Anybody know those names? I was curious. I was hoping they would be in this room. They could tell me about that, because it's a really interesting research they did. They published it for free, and there's a link down here below. By the way, the QR code on page 1 is a link to this presentation. So if anybody wants to follow along, there it is. Don't skip ahead, please. It's public, it's on GitHub. If anybody wants to fork and do this on their own, that's possible as well. Sorry, did you get that? Okay. Now, I say, this is what I typically see, H.264, which is the common codec. I think the codec even that camera's using. The quality as bitrate drops just drops off a cliff, right? Again, these were designed for NTSC, PAL, low resolution digital video, right? These codecs rely on today's more advanced computing. They have a lot wider range of features, a lot bigger areas that they check for diffs, and I'll show that a little bit in the algorithm how that works. And it's a much more modern approach to this. So good news for 2024, again, decoders. I've got one of each of these here. I didn't bring a 50-inch TV in my bag, sorry, but I've got a MetaQuest 3. People want to try later. I've got a 3-year-old tablet, Android tablet, that plays it just fine. And again, any TV based on Google TV or LG WebOS today, even 3 years ago, plays AV1, right? You stick a USB stick in your TV and it will play just like any other file, which is great, okay? And also, I should say I have examples of varying bit rates. So you can see the exact same clip go from 600 megs down to 40 megs. And it's, well, of course, you're all professionals, you'll see the difference, but I don't, okay? So today's GPUs, all generations from the 3 major providers support it, encode and decode, right? Intel actually was first, ironically. Intel Arc GPUs were the first to do native encode. with high performance and didn't make a lot of news, actually. I was surprised. NVIDIA followed. Personally, I run a 4070 Ti at home, and it can do up to something like 8 streams at once. AMD's work as well with the RDNA 3, I think. So if you use FFmpeg or anything that you're going to transcode or even record a live webcam like this in AV1, that can be done in hardware.
8 streams of what?
Sorry, streams of what?
Streams of which resolution?
Oh, okay. I'll talk about that actually, because this is even bigger. This is even bigger. Monster encoder, right? If I'm thinking about eight streams on like an NVIDIA 4070 Ti, ironically, it's memory limited because you have to expand all those frames into raw video. I can do about 5 or 6 1080 streams at once, 30 frames per second. I can do 1 or 2 4K streams, probably, and each one of those streams in parallel will run about half to 80% speed, maybe 1x, right? If I do the 1080 streams and I do 5 of them, often they will each run at about 5 to 10x the actual play speed, which is really great.
Both 30p, you mean?
Sorry?
Your UHD.
Yeah, 30 frames a second. HD, 30 frames a second, yeah. From H.264. I mean, it decodes and encodes in hardware, right? And that may actually be PCI bus limited because I have a PCIe version 3. Okay, so this is the one device that I was amazed by. I finally grabbed one. You can't get this in the cloud, ironically, anywhere. This is a niche product for the enterprise by AMD and Xilinx. So does everybody know what Xilinx is? They're the FPGA company, right? You can't just go on Amazon and order one of these. It's a half-height card, 40 watts, and it can encode alive up to 32 1080 streams at 60, right? It can do a quarter of that in 4K. And they advertise this with a server with something like 12 of them, right? Who is this targeted at? It's not actually targeted at traditional media companies. It's targeted at streaming, right? So again, Zoom or Twitch or anybody that's doing a live stream and they're doing hundreds of live streams at once, if they want to centrally cache that, they turn this around as quick as 8 milliseconds and it comes out as AV1, right? Then they can broadcast that out to the subscribers. Okay. I just got mine recently. It wasn't cheap, and it's software is kind of finicky because it's not consumer oriented, but it's very cool. If anybody actually is curious to try one out, they're hard to get. They finally started selling them on DigiKey, so I snagged one, and then I got whammed with the duty. I was surprised to see, oh yeah, this is shipping from the US. Very cool card though. And again, what I would love to see, there's 2 chips on here, so each one will do 16 streams. I would love to see a miniature version of this, right? I would love to see one of these in your phone be able to record your camera. That would be amazing, right? So the Google Pixel 8 supposedly has this now, and it's not been enabled in software. So suddenly your video camera can go from recording 4K at, what is the bit rate? Probably about 50 megabytes a minute to 10 megabytes a minute. That's a big deal, right? That'll save you on uploads, and it'll also save you on storage. Okay. So future needs, again, the market desperately needs a small edge encoder. For webcams, for security devices, one of the projects I want to do with this is demonstrate security camera, CCTV DR box doing 32 HD cameras at once, fitting on a 10 terabyte hard drive. It can do something like 9 months, sorry, 3 months to 9 months of continuous video. Right, so I looked it up. TfL has something like 180,000 known security cameras around London. Imagine the kind of data, right? And that's not centralized because I remember calling in a crime once. Yeah, someone just got assaulted on the train tracks. Oh, great, we'll send someone out and get that video next week. Right? Can you imagine? This is crazy because they have all these old security cameras that are locally stored. This has to be modernized at some point, right? And devices like this can do it. They're not cheap though. So. I would love to see a RISC-V platform. In fact, I was at RISC-V Summit to talk about rewriting and testing some of HashiCorp's software, our Go code on RISC-V. I would love to see open source CPU, open source encoder, right? It's all out there. Anybody can make a chip that does this without paying royalties. So this is a matter of time. I would love to see this show up on a Raspberry Pi or an Orange Pi or some device that suddenly becomes the world's best DVR or set-top box or essentially, 4-watt media server, right? That'll be the day, so hopefully soon. Wish list 2024. Now, my own experiences, and again, I'm honored to be here among professionals. I'm not a full-time media geek. I would love to be, but if anybody has any counterpoints or wants to prove me wrong or debate me later, tell me about it, because I'm curious what you think in the field and when you're working in the industry. Parallel encode, right? So you'll see someone say, I've got this new card and it encodes a 4K stream in 10 minutes, right? Well, that doesn't necessarily use all the hardware. So again, I found that on today's ADA generation NVIDIA cards, you can get the enterprise cards. Obviously, they will support more streams in parallel. Even the consumer cards can do, again, 1 or 2 streams at once. And then you find the hardware isn't being utilized because they can only take a certain stream so fast, right? When you split that up, do multiple streams in parallel, you get a better feel for the hardware, okay? When you're picking a bit rate, excuse me, always, let me go down, sorry. Yeah, so encoding benchmarks like parallel encode, don't forget to test how many you can do at once. And also constant quality bitrate considerations. Animation is easier, right? This analyzes color. It can actually take, if you go back to here, this thing is too touchy. If you go back to here, so this is the actual algorithm and how it works, right? We divide and conquer each block or super block into little blocks of a picture, right? It can do interblock and intra-block copies. So essentially you say, hey, this block of pixels is exactly the same as the pixels on the right side. Imagine in VR, right? You have parallel pictures, parallel images almost, except for a little bit of parallax between them. So you say, oh, well, the entire top right corner of the frame is exactly the same as the other side because there's 2 copies of essentially the same image. This is huge with VR. That saves a lot of data, right? These super blocks are easy to do in animation. You've got solid colors. You've got static backgrounds, right? Often I've seen a H.264 animation, and you can see a sample today. Again, go from 80 megabytes down to 5. And it's hard to tell the difference in a lot of cases. Okay. So I was talking earlier about with some people about like tape libraries. There's media companies with huge rows of tapes still, right? Some are not all in the cloud. If you are able to store that, archive that with another codec, suddenly your tape row becomes a tape shelf or a tape drawer, right? If you're going to the cloud, that's going to save you a lot of storage as well. If you need to transcode that on the fly to something that's consumable with your existing technology or H.264, that's easily done, right? Playback is simple. Anything can do the playback. Software updates on an older device, an older tablet often can do AV1 playback. Maybe not 4K, 8K, but often it has no trouble with 1080. Okay. Now, I keep drifting off here. Keyframe intervals and error correction. So if you're streaming on a broadcast and someone has bad signal, and I hope there's somebody here that actually has experience with this, because I'm curious myself, the differences between H.264, right, and AV1. This is not meant for something that you're dropping bits, right? Error correction is not part of the protocol. So the keyframe is there to say, okay, well, I've screwed up the image, I've lost data, and now it's all garbled with artifacts. Time for a fresh wipe, right? There's a fresh copy of the image, full screen, copy, now start over. Now we can move blocks around again, right? By default, this happens every 2 to 3 seconds in AV1. Some encoders will allow it to do intelligent keyframes and say, oh, the whole image changed, so let's do a keyframe, right? So someone panned from there to another clip, right? Not every encoder does this, but that is very necessary for broadcast. So imagine if you take this technology that's meant for the internet and you apply it to broadcast, where you had a maximum of HD, 1 or 2 channels on an actual chunk of spectrum. Now you can fit 4K channels, probably multiple 4K channels, if you can get this working correctly on broadcast. I don't think it'll happen anytime soon. There is one article that I found on this, somebody debating if they could do this. I would love to see it happen, because suddenly your one channel could potentially have 10 HD channels, where H.264 was only fitting 1 or 2 before with MPEG-2. I mean, broadcast is still a thing, right? People still use over-the-air. I mean, obviously my family back in the US does as well, right? So again, digital broadcast channels currently 1080p max. There's room for more. Either more channels or more resolution, right? And that will be coming as well. Now, Container is important. Okay, container type. Now, MP4 files, you've probably seen everywhere. They are widely compatible. They play on almost any player, any software, any hardware. The images, the video streams, audio streams can be just about any standard, right? Any codec. Because it's proprietary. So it can have proprietary and open source formats. But in my experience, at least, I've never seen anything that could play a partial file. So you download an MP4, halfway through, your mom picks up the phone, your download's dead, right? That's how it used to be anyway. You have to start that over, or you have to figure out a way to play half a file, right? So that's a problem with MP4. Not only do you need the whole file, but you can't stream it that way. You have to have the entire file. You can't stream it live, right? So the AOM came up with WebM, which is a progression, a new generation of MKV, Matroska format, which is partially compatible. Not every device will play it. Not every software will play it. It is open source, and one of the restrictions of that, it's nice that everybody can use it, and it can be supported without licensing rights, but it requires open source codecs then. So YouTube, this is mostly Google doing this, right? Live streaming requires either a libopus audio, one of the open source audio frameworks, and an open source video codec, AV1, VP9. And if people are not in the know, VP8 was the original version they released. VP9 was a more advanced one. VP10 was what they renamed to AV1, because it's not just incremental, it is a generational leap, right? AV1 is a huge change and a huge shift in the efficiency, okay? So you have to have those codecs. You can't add an H.264, H.265 stream to a WebM file, but you can then stream that, and you can play a half a file or an incomplete file. In fact, one of the coolest things you can do, I think, here's a CGI script. Right? All you have to do is dump out 2 lines to your WebSocket, your content type video WebM, and then the raw output from FFmpeg onto standard out. That's a stream, right? You can take that from a webcam like this, or you can take that from another file, or you can take that from any archive, right? I probably wouldn't use CGI in production. It's probably not the most secure, but that is as simple as it gets. You just take a file output, raw output from FFmpeg, and now you have a streaming service, right? Okay, so I'm about on time. And again, we have samples afterwards, if anybody wants to try out the MetaQuest. And also the video, if it works, and Paul is blocking me right now as I say this, but if that works, hopefully we'll try that on YouTube later. Again, YouTube, which is supporting the metaverse, is supporting the streaming in VR. If you've got a headset or an Apple Vision Pro and you go on YouTube app and it says, okay, 4K streams, 8K streams. There's not many 8K streams. And in fact, they're not 8K. And I was just actually talking about this over pizza, but if you browse for 8K streams, the only thing that they support in 8K right now is 360 video. So you can look up, down, left, right, all around you, but it is 8K wide and not the same aspect ratio tall, right? So it's actually just 8K wide stacked top and bottom for each eye, okay? If you go and get a 4K stream in VR right now, it's not 4K, okay? They actually limit it. I'm sorry, if you go to an 8K 180 stream, not 360, but 180 stream, so you can see front and back, kind of like this camera, that is actually capped at 4K. So it's not actually as big as it sounds because A, YouTube can't fully support it yet. B, most devices can't play it yet unless it's AV1. In fact, when you get that resolution, it has to be AV1. Otherwise, you're looking at streaming a 100 gig file, and YouTube isn't going to do that for free, right? Imagine getting an ad every 10 seconds in your VR stream, yeah, because it has to be paid for, right? So this is the future. In order for this to continue in the VR world to become reality, it has to be a more modern codec. And anybody with experience with H.266 or the new VCC that's coming out, I'm curious what your thoughts are. Cool. And thanks again for having me. It's been fun. I'm really, it's fun to talk to the professionals here. Cool. All right, we'll talk later.
Thanks very much for that. It's one of my favorite subjects. I spent 13 years chairing a VVB Audiovisual Codec Standardization Committee.
Oh, you're the guy to talk to then.
Yeah, we can geek out as maybe at the pub. But Yeah, so when I retired from that job, we were started looking at AV1, but we'd just done HEVC, AVC. One of the challenges we found with those codecs, and it was looking like it could be a challenge with AV1, but I'd like to get your opinion. One technical, one commercial. So the commercial one is that AVC was meant to be a nice low-cost IPR codec, and it turns out a few companies decided they wanted to get quite a lot of money from it, so it wasn't then commercially as interesting for a lot of companies as it would have been before. And the technical one was sort of streaming fairly high bit rates was fine, but then when you had to get down to broadcast level bit rates, with a high quality, on live sports, for instance, it became quite challenging because the processing power you needed was huge.
Yeah.
And getting a decent, picture at that kind of bit rate was quite challenging. So I'm interested to know how far that's progressed, since quite a few years ago when I last dealt with this.
Well, it was quite a few years ago, you say. So AV1 wasn't even formalized then.
No, AV1 was kind of like almost like a glimmer in people's eyes. They were just working on the standardization at the time.
Still calling it VP10 then?
No, actually, it was called AV1 still then. That was probably about 9 years ago.
This is interesting because the new generation of GPUs obviously use a finer fabrication, right? They can fit a more efficient encoder into that. But this is actually purpose-built ASIC. So Xilinx obviously makes FPGAs, and apparently I didn't know they made ASIC. So this is actually fixed custom hardware just for doing this, and the price reflects it. I was shocked, but I wanted to do this for fun and show a proof of concept with this kind of DVR security camera system and see if anybody was interested. So yeah, again, it's just a geek passion, I guess. But
yeah, it was interesting. It was that kind of, for us in the broadcast space, it's a lot about the decoder side. Can they actually get that to a sort of power and performance capability that works for mass volume at kind of 30 quid set-top box type price?
Oh yeah, now not a problem. I mean, decoding is easy at this point, I think. Yeah, interesting.
Cool, thank you.
What about the Apple problem, and where are Apple on?
Yeah, tell me about that, right? I every chance on a blog or comment thread I see, I kick Apple in the pants for that one. Like, you're part of the AOM, you join the AOM, the alliance for this, and yet you refuse to support it. Why? I don't know, right? M3, I think, now supports playback, finally. They're the last person of the party. You got the most expensive laptop in the market, and it doesn't do things it doesn't play video that laptops 4 years ago could. So I don't know. I wish they would call and let me give them an earful. I don't know. Yeah, good idea.
Thank you.
Encoding quality. There's encoding and compression and latency.
Yeah.
My experience of things like NVENC has been that it's great on latency, but it's diabolically poor at quality.
I've heard that too.
Or it ends up with vast files. You lose somewhere in the equation. Is that different for AV1? Or have you done any tests that have subjectively compared? I have, and there's the presets. Obviously, a lot of the NVENC standards apply to their H.264, H.265, and the same format, right? Obviously, if you need something now, again, this is literally engineered for 8 milliseconds, which not very cloudy.
No, not very cloudy. And again, this is targeted at the Zooms and the Twitches, and I guess Zoom uses Oracle Cloud. I've never seen one of these available in the cloud. That's why I had to buy one of my own. But I'm guessing that those streaming services have some special allocation privately in the cloud for these. Otherwise, AMD wouldn't make them, right? I will show you. I'll show you examples. And yes, I think it's prime time. I think it's ready now. Okay. And yeah, when it's live, you need special kit. It's never going to be perfect latency, but stored media, it's a win, I think.
And CPU hit for doing it over the other codecs?
Yeah, so that's gotten better. So there was the original AOM encoder, which was serially operated. It wasn't very optimized. And you'd sit and watch the case playing at 0.002% of the playback speed. That's the encoding speed. Like, that's never going to work. Well, Intel finally actually released not just their QSV, their hardware accelerated codec, but they actually released an Intel and AVX accelerated and optimized parallel software coder, SVT, right? The SVT API. And I find that on a decent sized box actually does pretty well. It can do real-time 1080, can almost do real-time 4K in a CPU.
Defining decent?
Yeah. No, in fact, the SVT quality is better.
But how big is a decent sized box in your estimation?
Dual 22-core Xeons.
So some cost.
Yeah, some cost. No, that's all on garage sales now because everybody's gone to the cloud. They're selling their...
Yeah.
Yeah. Anyway. Yeah, no, take a look at the samples. I'll sample your ass off later.
I'm not sure about that.
Time for one more, if there is one more.
Have you done tests with the Intel Arc board?
Oh, the ARC board, yes, yeah,
Much
yeah.
cheaper than
Yeah, yes, yeah. They are, but so I've done the A380, which is hard to get in Europe, actually. I found that Intel's not very good at keeping their stocks full in Europe. I had to order one from the US. And A380 was the intro card. So they actually have data center cards. They're flex cards that are meant for the enterprise. I haven't tried one of those. But the A380, which is the introductory level consumer card, it does like 2 streams, decent rate, but it doesn't do like an industrial strength job.
A lot cheaper.
Yeah, a lot cheaper. Yeah.
Like 300.
If you have the room to store 100 of
How
them,
much,
yeah.
how much they cost?
This?
No, the Intel one.
Oh, the Intel one. In the US, it's like $200. Here,
Yeah,
it's like
yeah.
350 quid. I don't know why.
Okay. How much does this cost?
This,
Oh.
after you pay all the sneaky duty fees and the shipping, it was like £2,000, £2,000. Yeah, yeah. It's supposed to be 1,400 quid.
It depends on the application, what you need to
Yeah,
do,
also
what to
depends
use
on
to-
if you have an AMD rep, you probably could milk them for a discount.
Thank you very
thank
much
you.
to John.
Lots of people use Amazon S3, but do you know how to do batch operations? Check out Victory's video right here.
I love the audience participation. I love the enthusiasm. Yeah, I love the fact that I have the professionals in the room. These people are legendary in this industry, so it's a great group. Like and subscribe.